Hello, still happy Christmas, Merry Christmas kind of time. Although we're heading towards the new year, so happy New Year if you're watching around that time. So I promised you snow. So what we're going to aim to do is make snow in this video. Also another little treat because it's kind of Christmassy time. Is get some sound working. I haven't done that in the previous Minecraft series of tutorials, so I'll do it now. So snow and some walking. Some walking noises, I should say. So to get things set up, actually, we need two files kind of ready, which you can just download from the link in the description, or more fun, make yourself. I'll just show you what those are. So if I just go to our project folder, so what you should have in your project folder is the main module, which is what I was just looking at there, the main Python code there. We've got mesh terrain, which looks after generating the Perlin infinite terrain. We've got a Perlin module, another module called Perlin underscore module, so that looks after all the Perlin functions and stuff. We've got a swirl engine for infinite terrain. We've got a mining system as well. Then I've got some other things. I've got like snow, snowflake, main copy. So those you probably won't have unless you download this whole folder from my GitHub link. So those you don't need. And of course the old code. So they're just my preparation things. Inside the assets folder, the two things I'm talking about is we need a flake underscore one PNG. So that's a picture of a snowflake. And then also for sound, they could be MP3s or OGGs. Ursina can work with both. So a stepping sound. So for example, let's just bring up both those. First a snowflake. Where are we? So there you go. So you can design your own snowflake. Notice that I've got transparencies. So all that checkerboard kind of pattern means it's transparent. That's why it's a PNG file. If you want to have transparency on any texture that you're using with Ursina or other things, a JPEG, a BMP won't be able to do transparencies. They don't have an alpha channel, but PNGs do. GIFs also have an alpha channel, don't they? So they can do transparencies. So you could do a GIF actually, like make an animated snowflake and stuff later on. Anyway, notice that the pixels are huge. So each one of these blocks of color is a pixel, and I think it's about 15 by 13, annoyingly. 1, 2, 3, 4, 5, 6, 7, 8. So it's about 16. Or 15, yeah, 15 by something like that. So you know it's about 16 by 16. That's the kind of resolution that I'm going to work with. Of course, you could change that later on. So there you go. So you can save that snowflake image in your folder, in your assets folder. So assets just meaning models, texture atlases, sound, all that kind of stuff goes inside the assets folder. And then if it's inside there, your main Python code can find it. Anyway, that's the flake. And I've called my flake underscore one, just in case I make some different versions. So I can call them underscore 2, 3, 4, and so on. Anyway, I've got that there. And now we need a step OGG file. I'm using, this is Audacity. It's a free sound manipulation program, which I'd recommend. Loads of people use it. And so you can like change the pitch, you can generate tones, all kinds of handy things, and you can export your files as OGG or convert them to MP3 and loads of things like that. So if you haven't got Audacity, I'd recommend Audacity, or use whatever software you want for handling your files. Just to show you what this is, if I press play, I found this online. I forgot where I got it. I really should have written it down. I think it's public domain, so that's fine. Anyway, it's less than half a second and just sounds like someone treading on soil or grass or something like that. So we've got a step sound. Okay, right, let's get working on this. So here's my main file. So let's start with snow. So what we want to do near the top of our main module, which is still only 64 lines long, where we're creating our terrain, let's create like some snowflake objects or something. So we want to spell flakes correctly. So flakes equals square brackets. So that means I want a list of snowflakes. And then I want to create those snowflakes. So I want to create a loop in range of, let's just start with 128 snowflakes, and then say E equals a new snowflake. So I guess I could call that flake. But that object doesn't exist yet. So that's what we want to write. And we want to write a new module so that we can do something like this at the top. We want to say from, and we'll call it flake module. So we'll write a new file called flake.py, and we're going to import that object, which doesn't exist yet. But we'll just write flake with a capital F like that. So it's very similar to, where we said from mesh terrain, that's from this mesh terrain module, I want to import the name of the class, which is a new kind of object that which we wrote, which is called the mesh terrain. So back in our main module, we say from mesh terrain, import mesh terrain, which is this object here. So we're going to create our own snowflake or flake module and our own, whoops, I'm in the wrong file, there we go, our own flake class. Sorry, in my prepared code I called it snowflake. In our real code I'm going to call it flake, so I don't get mixed up. Anyway, so we've created a flake, although that object doesn't exist yet, but then what we want to do is store that flake, store each of the 128 flakes on our list here, so that we can then go and update it later on. Or we can do whatever we like with those flakes. We might want to rotate them and make them fall and things like that. So then we want to say flakes, could you store or append or push that object, which is the temporary object, temporary variable, where we're storing each of the 128 flakes. We're going to store that on the flakes list, so we can then iterate over all the flakes and make them fall. So that's done. We've set up our flakes, so now we need to actually go and create that, that object. So I'm going to create a new file, and I'm just going to select, sorry, what am I using? Visual Studio Code, and it's handy sometimes to choose the language, right, for extensions and things. So let's just save that. Now this is the important thing, we've got to save this new module, which I think I called flake. We're going to store that in the same folder, so in our main project folder. So not in the assets folder, but in the main folder. So where our main .py module is, that's the important thing, save it in the same folder. So save that, and now let's use triple quotes, and then in between those triple quotes you can write whatever you like, and it's just a comment. So that's how to do comments over lots of lines. And it's traditional just to write what this module is. So I'm going to say snowflake module, smiley face, Merry Christmas, everyone. Okay, so we've saved that. I'll just go back to main. Did I definitely call that flake? Yes. Okay. So now we're going to create our new class, our new object. Remember, it's a capital F. It's traditional to call your objects by a capital letter. And we're going to do something slightly different here. Inside these parentheses, we're going to say entity, i.e. an Ursina entity. So what that does is inherit everything that an entity can do, our flake will do for free, just by writing entity in there, which is good. So this is something called object-oriented inheritance. Inheritance means we're inheriting something from another object so that we can use all of its properties, like its X, Y, and Z, its rotation, its scale. All of that is already coded inside the Ursina entity. So this is going to look a little bit strange, but it's fairly easy. So entity doesn't actually exist in this module. It does exist in our main module because we've imported Ursina, so we need to do that again in this file. So, but slightly differently, we're going to say from Ursina import. Now we're not going to import everything. We just need, at the moment, entity. So now we're happy. Entity, this module knows what entity means. Okay, so colon there to begin our class. And now we're going to write our initializing function. So I'm just going to go to the mesh terrain module to remind you. So the first thing we did there when we created our new terrain or mesh terrain is define this function double underscore or dunder init, dunder again, and this. Now we're going to do something slightly different because in our mesh terrain we're not inheriting from any other object. This is just a basic object that we're creating from scratch. So in our flake class, which is inheriting from entity, first we want to use the super keyword. So we're going to write super and then dot underscore underscore init underscore underscore and then open brackets. Actually, this should be taking place in our initializer. I think. No, wait a minute. I don't know what I'm talking about. Let me refer to my code. Oh, yes, I was right. There we go. I do know what I'm talking about. Yeah, that's fine. Okay, go back to Flake. Right. So first what we need to do is write our usual... Whoa! I pressed enter and it automatically did something. I'll be lazy. I'll be the opposite of lazy, whatever that is. Telling that I don't know what that word is, but the opposite of lazy, proactive or something, to write my initializer. And then we need this keyword, and that just means we can refer to this object when we instantiate individual objects. By the way, I must always say this. Traditionally in Python, this keyword is called self, but I don't like to call it self, I like to call it this. You should probably call it self, so everyone else who looks at your code knows what's going on. I'm going to use this because I'm, I don't know. Right, so we've got this. Now we can open this function, and now this needs to be inside our initializer, so they're not on the same line. So what we're basically doing with this, so everything's the same so far as what we did with mesh terrain, except for we're adding an entity inheritance at the top. So we started with def init, but now inside the def init, the first thing we're doing is using this super function. Now what this does is I'm trying to use a word that begins with super, like superimposes. Like, what does it actually mean? It means to overwrite. Does that mean like superimpose? Put in the comments if you know what it should be. It's on the tip of my tongue. Anyway, we're going to superimpose or write over the default properties that would belong to entity. So in other words, this will kind of look familiar. So when we're setting its module, sorry, not its module, its model, we can set the default one to cube or quad or sphere. We're going to actually set it to a quad in this case because each of our snowflakes just wants to be like a two-dimensional square falling from the sky. We don't want to have little cubes as snowflakes because then we're wasting all of those vertices. They're going to be 36 vertices instead of 6 vertices. So we can optimize our code, make it run a bit faster. Our texture in here is going to be our flake underscore one.png. There we go. So a quad is a built-in square shape from Ursina. So back to what we were doing. It's not liking that dot there. Maybe I shouldn't have done a dot. But what we're doing is over several lines. That's a traditional thing to do, but maybe it might be clearer for you to see if I do this. All we're doing is overwriting or superimposing the initializing function that we've inherited from entity. So we're initializing our flake's entity properties with these and anything else that we want to do in there. Why is that dot wrong? Oh, because I've doubled up my parentheses probably. No, it's still not liking it. Maybe there isn't a dot there. Let's go and check my prepared code. There is a dot there. So what on earth is going on there? I don't know. Maybe it's, I don't know. Oh, no. Oh, I don't need the def keyword. Because we're not, oh, yeah, we're not defining a new function. The function already exists in the entity class written by Ursina. So we just want to do something. We're not defining a new function. We're superimposing. That's not the verb. What is it? Just writing over that function, or like appending to it. Or are we? I don't know what we're doing to it. We're superimposing it with the super keyword. Anyway, I guess I could keep those in one line like that to shorten our module. But you might see it often like this. Anything in parentheses in Python we can put over several lines like that, which is what you usually see. In fact, you usually see it like this. So it's nice and clear. I'll leave it like that so you get the idea. Okay. Now, what do we want to do? We want to give those a random position around our player, I guess. So let's just take in a vector 3. Oh, I don't need to say the type, do I? I'll just call that pos. So that's going to be our subject position. Or maybe origin, orig for origin. And then I can say x equals orig dot or orig 0. Oh, you know what? Orig is going to be a vector 3. So actually I can say position equals orig. Now, if we're dealing with vector 3s, maybe we need to also import the vector 3 object. So I'm going to use the vector 3 object as it's kind of handled by Ursina, so I'm going to import it here. I've no idea how we've got to almost 20 minutes into this video. This is ridiculous. Okay, so we've got a position. And then I guess what we want to do, if I drop back one indent, so I'm now just inside the initializing function, so I'm not in this super thing. After that, I want to say our x plus equals, now I want a random number between -10 and 10. So I guess that's a range of 20 on the x-axis. So basically, all the snowflakes are going to be exactly where the player is, but then we want to shift them by a random amount, 10 either way. So I just want to say random amount times 20, so in a range of 20, but then, or from your perspective, a range of positive 20, but then I want to minus that by 10. So it's here or back here, like that. So minus 10. This random function doesn't exist. Oh, also, x doesn't exist on its own. It's this dot x. Now, I've inherited x from entity. So x means its position in the world 3D space. So that's done. And I want to do the same thing for its z position. And something slightly different for the y. I guess I want the y position just to be above the player by maybe 5 units, something like that. So z, so that's back and forward. That can be times 20 minus 10. So it might be behind the player or in front of the player by 10 units. But y wants to be plus, I'll say 10. It's going to be 10 meters or 10 units ahead. Now, random doesn't exist, so we just want to import that. So from random, the random module, we're going to import a function called random. So it's named the same thing as the module is called. And what that function does is just return a value between 0 and 1. Not exactly 1, I think you can go up to 0.999, so on. Right, so that positions our snowflake in a random position around our player, around and kind of above our player. We need to also change the scale of our snowflake. I don't know what by, so I'll just say scale is 1 for now, and just leave it like that, just to remind me later on to change its scale to like 0.05 or something, because they want to be really tiny, and like 1 by 1 is about like that big, so we want it a lot smaller than that. Okay, so now if we go back to the main module, what are we doing? We are, underneath terrain, we're creating a flakes array or flakes list, and then we're looping around a for loop 128 times, and we're creating a new flake object, which is an entity with a texture of a snowflake, and it's a quad. The model is a quad, so it's just a square facing towards you. And we're adding that flake, that entity, to our flakes list, just in case we want to use them later on. Right, so let's just try and run this. Whoops. Run that. And just see if we've created any bugs that crashes our code. Oh, we have. Missing one. Oh, when we create our flakes, we haven't passed in our subject's position. Luckily, above this code, we have created our subject, which is a first-person controller object, which means it's also an entity. So, because subject first-person controller inherits from entity. So I can just pass in there subject dot position, and position is a vector 3 object, so it has an x, a y, and a z component. Right, save that. Remember, you must resave your code before you can run it in Python and most languages. I think we're running this time. Yeah, we're running. Oh, and we've got snowflakes, and they look pretty big, but not too big actually. Oh, if I look at them from this side, they don't exist, or they're invisible. That's because a quad, and it does look like they're kind of like randomly positioned around us, a quad is sort of like two-dimensional, and it'll only display from one side. Luckily, we can get around that. If we go back to our flake module, we can also say, before we sort out the scale, I'll leave scale to the end, we'll say double underscore sided equals true. So that will just set any model that you're using, even a cube, it will now display from two sides. Yeah, if you went inside one of our cubes on our terrain, you wouldn't be able to see it. You would see straight through it. It's not double-sided. But if you wrote double-sided is true, the cube would also render inside as well. So it means it takes more computation to render. So you don't usually do this. So by default, it's switched to false. So that's sorted out. Let's increase this range a little bit. Let's say 40 by 40, so doubling those values. And actually, we wanted to go a bit higher. Well, let's go by 10 plus 5, because they weren't really above our head. They're kind of like from our feet. So our feet level must be about 0, I guess. Or our foot level is 0 for our y, if that makes any sense. That didn't really make sense. Ignore that last bit. Let's continue anyway. Merry Christmas. Kind of looks like the snow's falling. So yeah, it's more above our head, and we can see them from the other side, so they're now double-sided. Right, let's get these guys falling. And I think rotating would be nice. Okay. So, back in the main module, we've got a flakes list. And the reason for that, because we've not really used that yet, we've just put our flakes, or appended our flakes onto the flakes array or list. And that's because in the update loop, which iterates over and over and over and over again, what we could do is, before we do anything else, after the global stuff, we could say for I in range Now, what would be good programming is for me to write len for length, and then put the flakes list inside there. And then what this would do is evaluate how many flakes we've built. And then, if I made more flakes up here, I wouldn't have to change this code. If I try to iterate here over more flakes than actually exist, it will crash our code. So it's good to kind of just test how many flakes there are. However, that does mean this will have to make a little calculation, which would slow our code down, only by a little bit, but what I'm going to do is optimize it by just remembering how many I've got. We could have a single number, we could use like a variable in here, but I don't want to introduce another global variable up here. Anyway, I'll just remember for now. Anyway, so we're going to go over our 128 flakes, and then we can say flakes index I. So this number, as we iterate over, is going to go from 0 to 127. So that's 128 altogether. I'll just say that again. It goes from 0, so that's the first flake, to 128. No, 127. Because 0 kind of counts as 1, so it's 127 plus that 1, which is 128 in total. So by definition, if you put, or by default, if you put a number in here, it will go from 0 to 1 less than this number. And that's so that index or indices work automatically with this range. Anyway, so you want to get hold of flakes, and then what we want to do is move it down. So I could put y minus equals, so get less, by something like 0.1. And then I also want to times that by time dot delta time. So that basically means that the movement, or the rate of movement, the speed, will be the same across any frame rate that you have. So different computers, or if your computer's doing something else, it'll mean that the speed of those flakes will always be the same. So multiplying something by delta time is a good idea. If it's in the update loop and it's about movement, multiply it by delta time. Anyway, we don't really, though, want to do this. This is kind of exposing the machinery of the flakes inside the main module. We don't want to do that in the main module. We want to do that in the flake module. So what we really want to do, I'll just copy that code though, Control C, or Command C because I'm on a Mac. We want to just say, could you just do your physics? There we go. So I'm going to go and write we're going to write a physics function or physics method on our flake module in our flake class. So for I in range 128, just go and do the flakes physics. So in flake, we're going to add another function. So we've got our init function. So after that, make sure I'm in the right indentation. There we go. I want to define another function, and that's called physics. Remember, the first keyword has to be self, or in my case, this. And we don't need to pass anything else in. And all we want to do is, I can now paste that line. But I don't want to refer to flakes.I. I just want to refer to this individual flake. So I've written it once here, and all of these properties and methods and behaviors can be used by any of the flakes. Now, time.delta time doesn't exist in this module, and that's because I need to inherit it from Ursina. So let's just inherit time. There we go. Okay, I also want to do some rotation. Let's just see if they're falling. Back in the main module, I think I saved everything. Merry Christmas again. They are moving. My frame rate is dropping. I've only got 128 of them. Terrible. Anyway, that's the price of snow. I will work on better ways to realise this. Basically, we're making a particle system, and this is not the way to do it. So, but it could be used for other things. you can kind of get the idea. If you wanted to make like 2D trees or grass and things like that, you can kind of see how to do it from this code. Anyway, we want them to move a bit faster, and it'd be nice if they move by a random amount. So, in flakes, let's make them go a bit faster. So, we don't want to write this number 0.1. We want to have something like this dot fall speed times time dot delta time. And so for each individual flake, so if I go into the initializing function, this is where we can add its own properties. So I can say this dot fall, fall speed equals, and now we could randomize that. We can say random, so that's going to be between around 0 to around 1. That's about right, I think. And so when we create each flake will run its own initializing function, and so it'll decide its own position, random position, and its own random fall speed, which is good. That will not change for the rest of the program, so it will always fall at that speed, which will give us a nice bit of randomness, a nice bit of, not randomness, individuality for each flake. So they should be a bit faster now. Well, potentially 10 times as fast, some of them. So there they go. All falling at different rates. But we want to get them a bit faster, generally speaking. So maybe 4 times as fast. So back to the flake module. And let's just multiply their fall speed by 4. Go back to the main. Oh! Looks like someone's arrived at the house. Let me just pause this video. See you in a moment. I can't find pause. Oh, there it is. Okay, and I'm back, and I can't remember now what we're doing. Let's just try and run the code. I think we just sped up the random fall speed of each flake by 4, which is good. We've kind of got snow. Oh, these are really slow, aren't they now? So we definitely want to have a minimum speed. Also, when they've kind of hit the ground, then we want to reposition that flake above the subject's head. So, we want to say a random speed, whatever that is, plus, and now the minimum speed that we want. So actually, I'll write min speed, and then just as a temporary variable here, we'll say minimum speed equals 0.6. And then I've just used this variable because I could have just put 0.6 in there, but then it means... Oh no, my son Joey is having a time. Let me go and help him out. Okay, we've relocated, and Jojo is feeling much better. So hopefully the sound isn't too different or too bad here. Anyway, I haven't got my mouse with me anymore, so I'm just going to be careful when I'm clicking and things, so as not to disturb you too much. Right, so what we wanted to do is just check that, let's go to main, just check that minimum speed. Oh yeah, I was just explaining about the variable. So just to make the code more readable, without even having to use comments there, I've just used a variable name. So now we shouldn't have any of those strange flakes just kind of hovering in the air. But we've got like a minimum speed. So I think that minimum speed can be even a bit faster. So if I go back into the flake module, minimum speed, let's just say 1. There we go. Okay. So what we also want to do in the physics is, after we've moved you, we can then say if this dot y is less than, let's say 0, then y, then actually we want to run this code, but in terms of the the position of our player. So actually, in physics, we need to pass in the player's position. So I'll call that sub pos here. And let's write sub, nope, let's write, nope. This dot x, no. I want to copy this code. And I want to write this x equals sub pos dot x plus that. So it's going to be from the center of where our subject is, just like we did in the initializing function. But now, because the player may have moved, we want to kind of reposition that. So the snowfall will kind of follow us around. There we go. What would be better is if the y value of that snowflake hits the terrain. So what we could pass into here. Oh, I think I've done this in my prepared code. I kind of like wrote something. Flake update. Yeah, I've kind of done it here. We could use our terrain dictionary and get hold of the value of or the height of that terrain, or rather what we're doing is at this x and z position, is there and y position of this snowflake, are we inside a cube, i.e. have we hit the ground, then reposition the snowflake above the player's head to fall again, to kind of recycle all of those snowflakes. However, I'm not going to be that sophisticated and just say if I've got very low, then refall. Anyway, I'll let you, or maybe my future self, kind of improve this. Let's just leave ourselves a little note. We'll just say, would be better to just move that up, check if we've actually hit a terrain block. Kind of then, I don't want to be a smiley face, I kind of want to, but I don't want to be mad at myself, so just like kind of like a kind of playful, stern face. So would be better to check if we've actually hit a terrain block. Okay. And I haven't commented this code. Hit ground. If so, respawn above subject, above our player. There we go. And then looking at this code, you can see the random word. You're like, oh, okay, it's going to be a random position above the player. So this code makes sense. And also we can see this fall speed there. We know that, okay, this line must be to do with the snowflake falling. So what we do need to do is actually get hold of, when we're running the physics or calling the physics function from our update loop, we need to pass in the subject position. So actually, let's get hold of this subject position, so I don't have to type it out again. So in the update function in our main module, when we're looping over or iterating over all 128 of our flakes, we then want to say subject position. I want to pass that in. Okay, what I also want to do is make them smaller now. So our flakes, so in the flake module, yeah, I've got scale there, so maybe make them 0.1, so they're 10 times as small. And then run. Oh, now they look more like snowflakes. You can't quite see what they are. Oh, some of them move really close to your head. And that's fine. If we go all the way over here, I can still see snowflakes falling. Lovely. Right. I think I want them slightly bigger, or maybe just slightly more of them. So let's try that first. So back in main, I want to make 512. Then maybe make them slightly bigger. So twice as big as we just saw. And I definitely want them rotating. So inside the physics, we want to move them and then rotate them. So this dot rotation, and we want to rotate around the y-axis. So if you imagine a pole sticking through each individual flake, we want to rotate using that pole. So rotation underscore y, and we just want to increase that. So plus equals, and then we want, I guess, this dot rot speed. That doesn't sound nice. Let's call that spin speed multiplied by time.delta time. Again, we want it to run at the same rate on any computer, any frame rate. So we need to go and create a spin speed. And again, let's do that randomly. So I'm back inside the initializing function. So that means when we create each flake, we're going to give it a spin speed, and then it's going to equal random times 4. Just randomly. So that'll be between 1 and 4. No, between 0 and 4. Something like that. Okay. Right. Back in the main module, run it. So we should have more flakes. It shouldn't slow things down too much, and they should be spinning and slightly larger. So I've got a nice amount of flakes now. They are spinning, I can see that, but not very fast. Which kind of does look good. Oh, I love this. In real life, I love just looking up at the snow. You just get a sensation of infinity or something like that. So many of them coming down. Let's move around. I guess we should, talking of looking up, we should probably make some clouds. Now they are reappearing, which is good. But they were certainly a lot thicker to begin with. Yes, we just want to update the spin speed. So times 4 plus min spin. So our minimum spin speed will equal 2. No, maybe let's try 10. And then go to the main module and run. Oh, I can hear Jojo, my son, crying again. He might be hungry. It's about tea time. Don't worry, he's not here alone. He is being looked after. He's like, yeah, he might be hungry, but I've got to record this video, so sorry. No, he is being looked after. Right. They're still not spinning very fast. Let's have that a bit faster. Yeah, by the way, when you multiply anything by delta time, it usually reduces it by loads. So let's try randomness by about 40, and then minimum speed 100. And then, yeah, go back to the main module and run. I didn't look at my frame rate, actually. We are just ruining the frame rate, which we've worked so hard to keep at 60. But this is for Christmas. Okay, they're spinning a lot faster. That's perfect. That's a lot better. Oh, and I can kind of see them disappearing at about my eye level. So that's where 0 must be. So if I go higher than their spawn, oh no, they will be spawn. They will spawn higher than the player. Just looking above me now. So because I'm higher, it'll take them longer to reappear because 0 is so much lower. Although I don't see any of them. I know, something's going wrong. They should definitely reappear above me. Why are they taking so long? If I go down here, oh, they're appearing over there. So I'm pointing. They're right ahead. They're right ahead of me. Why are they appearing over there? Right, let's just go and have a look at the code. Well done if you've already spotted the bug. So it must be in here. This X position equals the sub position that we've passed in, plus maybe we need some brackets in here. Yeah. We need some brackets around our terms. So it was only an illusion before when I thought they were following us around. Right, it's just gone past the 45-minute mark. I really want to be able to do this within an hour. So I want to get our footsteps working. Then you could also add like music to your game. And oh, this is nice walking for the snow. And your own kind of footsteps and things. Or maybe you just want to fly around. So you could add like an engine noise and things like that. And one of the tricks that we use is change the pitch of the sound. Roughly speaking, increase the pitch, make the pitch higher when you're going faster, and lower it when you're going slower. Right. Ooh, that my frame rate was dropping. If I'm looking up, am I seeing new flakes appear? Yes, I am. Now they're appearing above me. So if I go and stand on a mountain over here, well, a hill, a snow-covered hill, we should this time get flakes appearing above me. Yes, I can see flakes falling above me as they gradually hit 0. Okay. Okay, so we've got snow kind of working. Well, it is working, but it's not very dense. It really hurts our performance. Drops us to like 15 frames per second, and isn't particularly dense. But we've got rotating flakes and things like that, so we've done something. Okay, so we don't need to do much code to sort out the audio. So as I said at the beginning of the video, before doing this, you do need a step MP3 or OGG file, and call that file step, and it should last about half a second and sound something like this. There you go. So if you've got something like that, that'll work fine. Or if you can't, oh, and this was called Audacity, by the way, this sound manipulation piece of software. It's brilliant and free. You could just download that file from me, from the link in the description, and then all you need to do is paste that into your assets folder, which is inside your main project folder. Or really, you could just put it in your main project folder, but it's nicer, more organized to put it inside of your assets folder. Because as we add more and more features to this game or the simulation, then this folder will get very messy. Okay, so now what we can do is, I'm back in my main module, we can create some sound objects or audio objects. I think they're just called audio equals, yeah. So let's call one of them, let's just call it step. Step equals capital A for audio. So this is an Ursina object, so we don't have to import anything else because we've already imported everything from Ursina. That's what this asterisk means. So audio is already there. So then the first thing we need to do is suggest what file we want. So we want the step.ogg. Next, autoplay, we don't want it to play from the start of our program, so we want that false. I'll just actually write autoplay equals false. We know that what that means. And then we want loop looping to be false as well. I think actually, let me just look at my code. I think that just means loop. Yeah, loop. That's what I need. So what this means is when it's played once, it won't replay and replay and replay. For background music or ambient sounds, things like that, you might want to have loop equals true. So you just ask it to play once, and then it will keep on looping, obviously. So we've got this this audio object. Now we want to play it. So when do we want to play it? Well, basically, we want to play it every time the subject steps. We've already written code that covers that in the update function. So I'm still in my main module. We're actually asking that. We're saying change subset position based on subject position. So we're saying if our player has moved more than 4 steps, then change the terrain. So what we could do is just tweak this or copy it. Actually, let's just tweak this. We'll say if we've moved more than 1 step, then I'll just add sound, smiley face, and we want to write step dot play, and that should now play. I'm just going to check my code. Where are we? Yep, that's all we have to do. Lovely. Let's just have a listen to this. Right. Does step actually exist in this this update? If not, we might have to add step as a global variable there. Let's just try and play. No, local variable step referenced before the assignment. So yes, we just have to add that as a global variable. There we go. And now play. Hopefully I haven't got this too loud or too quiet. I do want you to be able to hear it, but I don't want to, blast your ears off. Oh, int object has no attribute play. Oh, okay. So step is not a good name. Let's take it off there. I think it already means something in Ursina or in Python or something. So it's an integer. So let's just call it step underscore audio. And now back in the update, loop under here, instead of step, we'll write step audio. That's all gone blue actually, so it looks like I don't have to write step audio as a global variable. Let's just try running that again. Now conscious I've got about 6 minutes, is it? Before the hour? Okay, try and take a step. Wonderful. We can actually step. Now, it sounds rubbish because it's exactly the same step sound happening every step. So 2 things that we want to look at is, well, what ground are we actually stepping on? Because we want a different kind of sound. But also, let's vary the sound somehow. Now, we don't want to create or have to create loads of different step sounds to like give a random kind of effect by picking a random step sound. You could do that. What we could just do is change the pitch. So that's the high or the low frequency value attached to our sound. So what we could do, we could say step audio pitch equals, and then just ask for a random amount. I'm just going to have a look at my prepare code and see what I've chosen. So I've said plus 0.5. So that's going to be, actually, let's go for plus 0.7. That seems to be the default amount. And then play. Also, you probably noticed from my code, I've done some other things, which is also check if that sound file's already playing, then I don't need to play it again. I could just wait until that step is finished. Then if we've taken another step, then start playing it again. Anyway, let's just hear how it sounds at the moment. Oh, it sounds horrible. Module object is not callable. Now, is that the random or is that pitch? It looks like random looks okay. So it's probably pitch. Let's have a look. Pitch looks fine. So maybe we can't change the pitch if we're actually playing the sound. So let's say if step audio dot playing equals false, then change its pitch and then play it. So it'll only start changing the pitch and start playing if it's not already playing. I think that's what that not callable thing was about, that error. So I'll only be able to see if I start moving. Here we go. Oh no, it is something else. Oh. No. If step audio playing, have I written that correctly? I know I've done the logic slightly differently. I've used the not keyword. Yep, that's fine. Have I done anything different here? Autoplay is false. Loop is false. Let's go up and have a look. Autoplay false. Loop is false. Step.ogg. If we've got, we are in the update loop. Is that where I did it in my prepared code? Yes. Just make sure I'm in the correct indent loop. Sorry, indent block. Yep. And surely I've got random in here. Oh, I don't know why I've got enum. Oh, I don't think I have got random. So it was the random function. So from random import random. Well, that's what I'm hoping. If it isn't random, then I'm flummoxed again. So save that. Run. Oh, we've got less than 1 minute. Oh no! Module object is not callable. What am I doing wrong? Oh, I wish I was kind of like live streaming and people could tell me. In line 56 update. Let's go right to the top. What's happening? An error code while compiling. Oh no, that's fine. Traceback. That's the error. In update, line 56. Module object is not callable. Step underscore audio dot pitch equals random. Oh, random's gone blue here. From random, import random. Let's have a look at my prepared code. Now it's orange here. So why why isn't it orange in my other one? Well, I'm importing it after Ursina. That might be the issue. Let's try that down here. Save. What color has it now gone? No, now it's gone orange there. Why? Step audio? I don't need it as global, surely. No, that's not it. Now let's try and run. Oh, this is terrible. Oh, it's taken me over the hour. This is not what I wanted to happen. Now it's working. Okay, so what I changed was the order of import. So it might be Ursina uses random, or one of the math modules that's used by or handled by Ursina. Oh, that's really nice. A nice rotating snowflake near our face. It's made it all worth it. Merry Christmas. Thank you for the struggle. One last thing, since we've gone over the hour, one last thing is, if we went up here, it'd be nice to have the sound of snow. So one hacky way to do this, is, in my prepared code, what have I done? I've basically I've set up with a new sound. So I haven't changed things via the pitch here. I've actually created a new MP3 called Snowstep, and I've called this Snow Vox. Vox is just like Latin for voice. So let's just copy that and put it in our code. So near the top, we'll make a new audio object, and I'll call it snow underscore audio. And actually, let's just call this grass audio. And then how high do we need to be? And then I'm saying if our subject's position is greater than 4, then play snow. Because at the moment, if our terrain is above 4 high, then there's often snow there. So down here, I just need to say if subject dot y is greater than 4, then if snow audio playing dot playing is false, then snow audio dot pitch equals random plus 0.7, though I think I need to change that, and then snow audio play. And now corresponding to the if our subject is higher than 4, I can say elif or else if step audio, and not step audio, this is now grass audio, so I know what kind of stepping sound we've got happening. If our grass audio is not playing or is false, playing is false, then I can leave that code alone, that already works. Now with my snow audio, I've just fiddled with the pitch, so I want it to be random amount plus 0.5, but then take off 2.5. So that's just going to be plus 0.25, isn't it? So I think that's supposed to be times something. Anyway, so what was that? Plus 0.25 for the snow. It doesn't sound great, my snow, but it sounds like something. It sounds like something approaching what snow should sound like when you tread in it. Although I've forgotten now, it hasn't snowed for ages. So, random steps. And as we go onto the mountain, it sounds very quiet. I might, sorry about if this blows off your headphones or something. I kind of like it, even though it's kind of rubbish. It kind of sounds really muffled. Anyway, better switch this down. Right, there we go. Happy holidays, Merry Christmas. We've got snow and some stepping sounds. So what we want to do next, as someone suggested very wisely in the comments on video 5, we need to do building next. So I think building, getting some trees, and saving and loading terrains would be brilliant. And then we'd be in the same position. We've caught up with the other series in a few videos. Right, thank you very much for watching. Welcome to 2022, if you're watching in 2022. It's still 2021 just about for me. So thank you very much and goodbye.